Hello everyone! Today let's talk about IPv6 addresses. When it comes to IPv6, the first thing you may think about is its large number of addresses. Does IPv6 only expand the network address space? We hope that today's video will help you understand there's more to IPv6 than simply the massive address space. So why are IPv6 addresses introduced? Let's have a quick look. In 2022, there are about 7.9 billion people worldwide and more than 4.6 billion netizens. We can see that 4.3 billion IPv4 addresses are insufficient to meet the requirements of Internet development. So, a higher IP version supporting more IP addresses are required. IPv6 addresses are extended to 128 bits, meaning that each grain of sand on Earth could be allocated an IPv6 address. What problems can be solved by the massive number of IPv6 addresses? First, the IPv6 address space is large. The large public address space makes the use of private addresses unnecessary. This solves private address conflicts during private network integration and eliminates the need for net processing, thereby reducing device performance consumption. Second, many non-contiguous IPv4 addresses are allocated. Routes cannot be summarized effectively due to incorrect IPv4 address allocation and planning. IPv6's huge address space facilitates hierarchical network deployment and route summarization. Third, the huge IPv6 address space can technically solve the problems of network real name authentication and user identity tracing, implement precise network management, facilitate backtracing, and improve security assurance. Finally, the significant increase in the address space enhances security. The length of an IPv6 address is up to 128 bits, which reduces the possibility that service systems are scanned by Internet detection engines. For a 64-bit network prefix, there are 2 to the power of 64 addresses on a network segment. If an attacker scans addresses at a rate of 10 MB per second, it takes about 50,000 years to traverse them. Compared with IPv4, IPv6 greatly improved anti-hacker sniffing and scanning capabilities of addresses. If each grain of sand has an IPv6 address, how do we configure so many addresses? On an IPv4 network, if you do not want to manually configure IP addresses, you have to use a DHCP server to automatically allocate them. IPv6 addresses can also be manually configured, or DHCPv6 can be used for stateful address allocation. On an IPv6 network, if you do not want to manually configure IPv6 addresses, you can use stateless address auto-configuration without the need for a DHCPv6 server. Specifically, IPv6 can use the neighbor discovery protocol to perform router selection and advertisement. After receiving an RA message, a client parses the IPv6 address prefix carried in the message and automatically generates an IPv6 unicast address based on the prefix and the local interface ID. What are the advantages of IPv6 address auto-configuration? First, true plug-and-play is implemented. When a host is connected to a network without a DHCP server, the host can access the network without manually configuring an address. Second, network migration is convenient. When the network prefix of a site changes, the host can conveniently perform readdressing without affecting the network connections. Third, network complexity is reduced. No independent DHCP v6 server needs to be deployed, simplifying network planning and operation and maintenance. IPv6 addresses are classified as unicast, anycast, or multicast addresses. Unlike IPv4, IPv6 does not have broadcast addresses and inside uses multicast addresses. In addition, IPv6 supports anycast addresses. Let's take the interaction between a carrier and a user as an example to describe the three types of IPv6 addresses. If a carrier sends birthday wishes to a user on the user's birthday, this P2P mode is a unicast address transmission mode. If multiple users have the same birthday, the carrier adds the users to a group and sends the birthday wishes to them. This P2MP mode is a multicast addresses transmission mode. If a user requests a service by dialing the carrier's phone number, and the nearest set receives a call and offers the service, this point to nearest point mode is the anycast address transmission mode. Why are broadcast addresses removed? First, IPv6 uses abandoned multicast addresses to replace broadcast addresses. After broadcast addresses are removed, devices do not receive broadcast data packets and therefore do not need to parse such packets. This prevents performance consumption caused by parsing broadcast packets. In addition, because there's no broadcast mechanism in IPv6, the risk of broadcast storms on IPv4 networks does not exist. IPv6 does not allow fragment overlapping, which mitigates common fragment attacks in IPv4. Why are anycast addresses added? The advantages of the anycast mechanism are that source node can receive specific services without knowing serving nodes or the current network situation. Finally, let's review today's introduction to IPv6 addresses, introducing the problems that massive number of massive IPv6 addresses can solve. IPv6 address auto-configuration and its advantages, and the classification and the benefits of IPv6 addresses. We hope that you appreciate the benefits of IPv6 addresses. IPv6 addresses are the key basis for intelligent connection of everything. We will accelerate the large-scale deployment of IPv6 and build a fully connected, intelligent world as soon as possible.